Alright, so we have a couple of tougher formulas to solve. This one usually comes in some number theory when we're counting some numbers between like 0 and 100. And then this one actually is the surface area of a cylinder. Alright, how much area do I have like in a can of Coke? So they actually have some real life meaning. And but here we're just going to concentrate on solving for the variables they ask for. So for starters, here they're asking us to solve for k. Alright, since I have a fraction, we've seen that one of the classic ways to start solving an equation with a fraction in it is to multiply both sides by the LCD and clear it. So when I do that here, I get 2n equals k squared minus 3k. And then now this presents a problem for us, because unlike the last couple of triples that we've done, it is possible to get the b by itself. But here, right, we do have a couple of k's, but one k is singular, right, to the first power, and the other k is squared. So we're actually looking at a quadratic here. So as far as k is concerned, this is a quadratic equation in k. So what do? Well, we usually move some stuff around, right? We set it equal to 0. So how about I do that by subtracting 2n from both sides? And this looks a little odd, but keep remembering this is a quadratic in terms of k. So the way we're going to solve it is by using quadratic things. I'd like to factor, but that n is throwing me off. If that n wasn't there, we could probably get it done, right? We can use the completing the square trick, right? But you know, that's already a 3, and that's not easy to do, as we've seen, right? Dividing both sides by 2 already introduces fractions. But how about the quadratic formula, right? The good old quadratic formula, x is negative b plus or minus b squared minus 4ac over 2a. So I'm basically going to use that here as I solve for x, right? But here, right, we're solving for k. And if we look at this, right, the variables, right, a is equal to 1, right, that's the leading coefficient. B is equal to negative 3, right, that's the coefficient of that term. And then rather than being a number, this just means that c is equal to negative 2n. So in terms of solving for k here, right, I will just basically make my substitution. So I'm going to negate whatever b is, plus or minus whatever b is squared, minus a 4 times an a times a c, all divided by 2a. So as far as k is concerned, there's my a, b's, and c's that I throw into my quadratic formula, since we're looking at a quadratic in terms of k. Cleaning this up, right, if we negate negative 3, we get positive 3. Inside these parentheses here, negative 3 squared is 9. If we multiply this together, right, I've got a negative and a negative, so we're going to end up with a positive. 4 times 2 is 8, and then I'm kind of carrying that n around all over 2. And as far as simplification is concerned, there's not much more I can do there, right? We know the radical doesn't break up over a sum, right? We can't really combine like terms here. So essentially, as far as solving for k is concerned, this is the best that I can do. Somebody would have to tell us what n was equal to, and then I would be able to substitute that value for n and then actually get a numerical value for k. But right now, since this is a formula, that's the best we can do. So what made this a little bit tougher is the fact that the variable I'm trying to solve for, right, is written differently in two different aspects, right? It's squared and it's to the first power. So as I do my golden rule, we find that we have a quadratic in terms of that variable, so I'll just make use of the quadratic formula in terms of that k. I'll note what a is, what b is, what c is, throw it in the formula, and then take it as far as I can go. Same thing is going to happen down here with e. I'm asked to solve for r. And so if you take a look at r, right here r is being squared, and right here r is to the first power. So we have another quadratic as far as r is concerned. So how do we solve a quadratic? Well, set it equal to 0. So we get 0 equals pi r squared I'm going to rewrite that as plus pi SR and then minus A. And so as far as R is concerned, A, right, the leading coefficient is this pi. B is pi times S, and C is negative A, right? Sorry that I'm kind of redundant with my A here, right? But this A is for the formula, and this A is for the formula we're currently trying to solve. So we'll just try to keep that straight. Maybe I should have used some lower cases. But this means that using my quadratic formula, R, right, is negative whatever B is, which is pi S, plus or minus, we're going to take that B and we're going to square it, minus 4 times A times my C, all divided by 2A. Alright, so again, we've got R solved for in terms of its quadratic form, but you'll notice that this S and this A are throwing us off because there's not much more I can do here except to kind of clean it up. R, this would be a negative pi times S. This would be a pi squared S squared. A negative times a negative is a positive, and it looks like we get a 4A pi, all divided by 2 pi. And that, without somebody telling me what S is and what A is, I can't get a numerical value for R. I can just have another formula, right, in terms of R, and it's pretty complicated, right, but that's basically how we do it. So you can see a clear difference between solving these formulas up here, where it was possible to get the variable I was trying to solve for by itself and just, you know, continue to hammer away with it, as opposed to D and E here. The variable I'm trying to solve for is in squared form and in the first power form, which means in terms of quadratic, it's a quadratic in terms of that variable. So I'll set it equal to 0 and take advantage of my quadratic formula to get the job done, and then unfortunately that's as far as we can take it. Alright, so there's basically your introduction to one of the first ideas in section 11.4, which is to solve formulas for given variables using quadratic ideas. Alright, I'll see you in some more word problems coming soon.